Hey everybody. Um, I had not heard that story until just a few minutes ago, so I've got a lot to live up to. Um, I'm here to talk about what it means for code to be maintainable. As I said, my name is Mike. You can find me at Lazer-Walker pretty much everywhere on the internet. Don't actually go to MySpace. I don't think that's me. Um, I make iOS apps. I do a lot of consulting work. I also make sort of experimental games and weird art pieces by myself. But as I said, today I'm here to talk about what it means for code to be maintainable. That sort of recently I've been reading a lot of articles and technical books and all these things where they'll introduce a topic or a tool or a design pattern by saying, if you use this, this will make your code more maintainable. But they never really dive into what that means, or why is this idea more maintainable than a similar idea. And I was really interested in diving into, what might it mean for your code to be maintainable? How can we assess maintainability? Can we have some sort of framework for thinking about this? So I'm going to start by talking a little bit about extreme programming. For show of hands, how many people in here are familiar with extreme programming, maybe other sort of serious forms of Agile? Okay, a fair number of you. So extreme programming came about maybe the mid-1990s, mid to late 90s. This guy named Kent Beck. That it's sort of a very opinionated, agile way of working. You pair 8 hours a day. You test drive everything. And for him, extreme programming is all about minimizing the cost of change. This idea that you're going to be making arbitrary changes to your code base. Maybe that's a bug fix. Maybe it's a new feature over time. The cost of that arbitrary change is going to look like this. You can see I had my finest graphic designers make fancy graphics. That if you're working in a traditional waterfall method, et cetera, the more code you get, you're going to get this exponential growth of your code is going to be so complex and everything's going to be tied into each other that it's going to be really hard to make changes. And his hope through something like XP was that we can make that graph look a little more like this. That we can keep this average cost of change down, we can make our code maintainable, we can write code more easily. You probably can't get that flat, but we can get close. And I will try to go through a bunch of these ideas quickly since it seems like a lot of you are kind of familiar with XP, but a couple of sort of big high-level ideas that are important. I'm not going to touch on all of them. One is this idea of YAGNI, or sort of you want to do the simplest way to do anything. There are a couple reasons for this. If you're sitting and saying, hey, here's a problem, here's a generalized solution, let's implement something complex. If you don't actually need that complexity yet, you now have to deal with that, and you have to deal with maintaining that, and you have that overhead of all this code before you really need it. More importantly, you don't really know the best way to solve the problem until you have it. If you don't need to make an architectural decision now, the only person who knows better than you right now what the best solution is you a couple months from now, when you have much more context on what the actual problem you're trying to solve is. Another big thing with Agile and XP and all this is automated testing, specifically TDD. Hopefully I'm preaching to the choir, but testing is awesome. There are lots of reasons to test. Everyone talks about catching bugs. I think that's actually the least important part of testing. That really thinking about how to test your code gives you better architecture. Both sort of the act of how do you write code that you can test is going to encourage modularity and all these other great design principles, but also just the act of having something else that's calling your code, writing tests for it as you're writing your code is going to get you to think about architecture and think about what is a better way to structure this. Also, these last 2 points are sort of tied together, that as you go to parts of the code base you're not familiar with, maybe you're new to the code base, maybe a coworker wrote it, maybe you wrote it a year ago and you forgot it, a big part of the cost of change is you need to make sure you're not breaking things. And if you don't know what things do, that's really hard. So having a safety net that if you have all these tests that let you know if you break things, that is beautiful. You can move fast and change everything, although hopefully not. It also gives you great documentation, and that if you look at code, even if you can figure out what's happening, you might not know which bits of complexity here are intended and essential to the business domain, which you have no idea, they just sort of exist because they're there. Having the fact that a previous developer wrote a test to say this matters, that tells you a lot about what is sort of essential complexity in your code base. So what I'm really interested in looking at is, when do these ideas not work? So I used to work at Pivotal Labs, which is a big agile consultancy. I've heard them described as sort of the reference implementation of XP. And going there, it sort of opened my mind to this whole world of, using all these principles can totally change the way you write code. I didn't know programmers could be that productive until I worked there. Since then, I've been doing a lot of early stage consulting work with early companies building rough prototypes. And I'm almost ashamed to admit this, but I don't write a lot of code or a lot of tests anymore. Because if I'm working on all these projects where I am the only developer, and these projects are small enough that I can keep all of them inside my brain at once, I don't forget sort of what exactly is going on. I still get benefits from testing, but I don't get any of that refactoring safety net, the documentation, all these things involving knowledge transfer don't apply as much. So the cost of writing tests is sometimes, greater than the benefit I'd get from them in the short term, which that's the key part. But if I'm working with clients where they have 6 months of runway, they're trying to throw something on the App Store quickly and see if they have a business, it's worth that trade-off to make that 6 months go as quickly as possible without worrying about, are we screwing ourselves a year from now? This is generally not the case. Please don't take this as don't write tests. Tests are amazing, but sometimes they're not the right tool for the job. Similarly, on the other side of the spectrum, if you look at Facebook, maybe you've been following a lot of the open source iOS work Facebook's been doing. Maybe you saw Scott's great talk on async display kit this morning. Maybe you've read about components. They have a large number of projects that basically boil down to, we're trying to do things in scale equivalent to rewriting UIKit, which at first bluff, that sounds ridiculous. Why would you do that? There is no way that is the simplest way for you to solve this problem. You can build Facebook.app without doing that. In fact, Facebook has. But Facebook has hundreds of iOS engineers. And if you think about it, it starts to make sense that you can throw a dozen people on this weird, crazy, gigantic project, and that's actually going to reduce the cost of change for everyone, even if this seems like you're designing everything from the start. Scott made a really great point earlier today about how sometimes, sitting down and designing really sort of overarching frameworks with really strong goals, you can sometimes accomplish more than with micro frameworks. And you can't do that as easily with this sort of approach. So the overarching idea here is, what might work to minimize this cost of change for a couple people might be different than for a couple dozen people, might be different for a couple hundred people. And similarly, the way you think about this for something you're throwing together over a weekend might be different than if there's something you need to maintain for the long term. And even going back to the Agile Manifesto, that is sort of what Agile is all about, the idea that you don't blindly follow things and say, this is the way to write code. You have to think about what's appropriate for your team, what's appropriate for your process, what's appropriate for your code base. But of course, even if you think that way, the way you get a team of a couple dozen people is you start with a person or two. The way you get to a couple hundred people is you're a couple dozen people who are really successful. So any thinking about maintainability really has to keep this in mind. Specifically, I think many or most projects reach this point where you hate your code base so much that you think, oh, I have to throw it all out and start over. But if you're looking at sort of this idea of the cost of change over time, if you decide to go through with it, you're probably going to get that huge spike. And if you decide to go through with it, maybe you'll be successful. You'll probably be very, very late. You will probably have a lot of bugs because there's all this sort of cruft in your code that actually represents real business problems you've solved. Probably not the right choice, but it means that, when we're thinking about maintainability, we have to keep that in mind. You can't just think about the short term. You also can't just think about the long term. You have to, sort of managing that transition is really hard. And full disclosure, I don't have the answer. There is no silver bullet. I'm going to talk about a couple ideas, a couple things that I've found useful. But this isn't really that much of a solved problem. So one way this talk could go is I could go through and talk about all these specific tips and tricks that people often do. A lot of these tend to boil down to how can we keep our code as separate as possible, so instead of rewriting everything at once, you can rewrite one piece at a time and make sure that those little things don't affect each other. Instead, I'm going to talk about a couple more specific examples that might be instructive in different ways. So I'm going to talk about singletons, which is a very contentious subject on iOS. This is a design pattern. Many of you are probably familiar with it. You have an object, you have exactly one of them, and you have a global way to access it. In general, these are considered bad, 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 bad. If you Google for them, everyone tells you they're terrible, which isn't, they're not a bad design pattern, they're just usually used incorrectly. I think where you find these a lot on iOS, this is sort of what they look like in Xcode. If you use the Xcode snippet, Apple uses these a lot themselves in ways that are perfectly reasonable. If you were using an NS notification center, it's sort of a pub-sub mechanism if you're not an iOS developer. If you're subscribing to messages or emitting global messages, if you want to listen to things from the system, you want to make sure that you're using the same one that everyone else is. Conceptually, you only have one application, so you want a way to get that one application. The problem is a lot of engineers take this to mean, okay, we should use this pattern on our own. You take something like a user object. This is a really convenient way to get to the user. Sort of ignoring, there are a lot of reasons this is bad. In a lot of ways, this is going to hurt maintainability. I think it's not particularly interesting because this is all sort of very well talked about. But it's worth noting that this is worse on iOS than other platforms. If you talk to people in other languages, this isn't even really a debate. Yet, on iOS, every couple months, there's this giant blow-up on Twitter of, should our third-party CocoaPod be exposing a singleton or not? And I think a lot about Objective-C makes this more appealing, that this becomes sort of a more regular pattern, that it becomes easy to inject that anywhere, but in the long run, it's painful. But if you look at our alternatives, they're not great either. Oops, that's, okay, sorry. Yeah, so the thing about this user example is it seems like a logical assumption that you will have exactly one user object that lives across your entire app's lifecycle. Maybe you can fudge it for logging in and logging out. But a famous counterexample is you go to Dropbox, they made this assumption, and then they shipped a feature where you can be logged into multiple accounts at once. And you can start imagining that refactor looks really nasty. You have to find every single case where you're calling that singleton and figure out a way to refactor it. And it's not pretty. So the typical solution that sort of is generally agreed upon is called dependency injection. A lot of people who, more junior developers who've never used it sound scared by the idea, but it's really simple. This manual dependency injection, you just, instead of a random object that needs a user, instead of it calling out to a user, it'll have something else pass it in a user. Maybe that's a mutable property. Maybe the method that needs a user will take it in. Maybe the constructor will take in a user. In Objective-C, though, this can often turn into this. And you're now managing giant constructors that take in all these objects. You change that, you have to change those constructors everywhere. Typically, if you see this, this is probably a smell that that object is doing too much and should be broken up into other things. You're still going to run into the problem that, you know, the way a lot of Objective-C apps are architectured, you might have an object sort of a couple layers down in your app that needs something that originally comes from way over there, and all of a sudden you have 4 or 5 objects that have to know about this dependency just to pass it along. Which is really, you know, that I've seen that be a major point of friction in a lot of apps. That changing one thing means you have to change 10 classes that shouldn't have any reason to know about it. And so in many other languages, this is an easily solved problem. If you're writing Java, you just use a DI framework. This can be tricky in Objective-C, partly because the syntax makes this a little nasty, but also culturally it's not really a thing you do. Which, again, there are many reasons for this. Probably a lot of it has to do with the syntax. But it means if you're picking up this new third-party dependency, you have to worry about, is this maintained? You have to teach all of your developers how to use this because they're probably not familiar with it. Onboarding a new developer is probably going to be tricky. So we're sort of left with these 3 options, neither of which is ideal. We have singletons, which, you know, in the short term, it's going to make it really easy to just get what you need to do done. But in the long term, it's almost certainly going to cause you to hit a wall. We have this manual dependency injection, which is probably the right choice, but you really have to be careful to make sure, you know, you're not causing problems for yourself. Or you can use this framework, which is going to have a higher upfront cost, but is probably going to pay for itself in the end. And that's a really hard trade-off to make. You know, maybe not as much in this circumstance, but those same 3 sort of options will show themselves in a lot of other circumstances. As a quick side note, you know, I find as much as sort of everyone knows this is a bad way to do things, maybe 90% of the client code bases I inherit have singletons somewhere. And it can be really effective if you want to try to refactor these out. You don't have to immediately kill them. You can just sort of slowly introduce dependency injection. And then like in this example, if you need to change the way that user singleton works, that view controller object doesn't need to know about it. If you're writing tests, you can easily stub or mock out the user defaults or the user object. These aren't necessarily 3 standalone options. To change track slightly, the next thing I want to talk a bit about is sort of what it means to think about your code base. So most of the people in this room are probably mobile developers of some or designers of some kind. You typically think of your app having end users. These are people who download the app. There is some design to the app. The way you or your designers think about the UX of your app affects the way people use their app, affects the sort of experiences they have. That's pretty straightforward. Similarly, you might have a third-party API. You expose an API to other developers. The way that you set up your object graph, the way these header files look like, this is going to influence the sort of apps people can build on top of it, the way they will build things on your platform. But in a sense, your engineering team is also sort of a consumer of your app. That the sort of space you build, the way that you can write code inside your environment, that's going to influence the sort of code you can write and how easy it is to do things. And specifically, I think there are a lot of cases where it's worth increasing complexity in your code base if it means that you can decrease that complexity in the right place. And if we sort of switch metaphors from this design thought to sort of performance optimization. If you have a performance problem in your code base, you're not going to go and find, what is the one place that I can speed up the most? Because if you can speed something up 100 times, if that's only 5% of your problem, that's not going to do much. You find the part that is, this is the part that is consistently causing you trouble. And even if you can speed that up a tiny, tiny bit, that's going to pay giant dividends in terms of increasing your performance. And we can think the same way in terms of our code. That if there are parts of your code base that are just a major, major pain to change, but are also really, really important and change often, you probably want to fix that, and it's probably worth doing whatever you can to fix that. So as a quick example, I maintain a library called IntentKit. This is a library for third-party app linking. Say, if you have a link in your app that you want someone who's going to tap an address and they want turn-by-turn directions in Apple Maps, normally you just construct an Apple Maps string, open that URL, but a lot of users want Google Maps. And you could do a lot of this checking yourself, figure out which app do they have installed. Do you want to show them up a prompt and let them pick? How do you manage these preferences? This sort of manages this in a sort of generalizable way. It works for maps, web browsers, mail clients, all sorts of stuff. But specifically, this has a really weird design problem in that it provides user-facing components. It's got a third-party API for developers who want to integrate this in their apps. There are people who jam on the code and make it better, but there's also sort of a second set of third-party developers. People who say you make Google Maps or you make MapQuest or some arbitrary application. If you want to add support into IntentKit, you need to work on that yourself and add it in. And so thinking about designing this, sort of the two most common use cases are either going to be developers adding this into their app, or those people pull requesting in. So to me, those had to be clearly the simplest things to do in the code base. And anything else sort of is secondary, because the way to reduce the cost of change overall in the code base is to take these tasks that are overwhelmingly, this is the way people use this, and minimize that. So a couple things that happen there is focusing on what parts of your application are data and which parts are code can be really useful. The thinking about how would you add Google Maps support, you could very easily see someone having to subclass something or introduce something like that. But instead, it was really important to me to say, you should be able to pull request this in without changing a line of code. Since conceptually all this is a mapping of types of actions you can do to URLs. And having this sort of plist be the way you do that had some unfortunate ramifications in code. You see all those template strings being included. That makes it really easy for people to make typos when developing. So there's a whole set of testing around this to make sure that each of those property keys are valid. It's not great, but it's worth it because it makes this part that much easier. For a little more contentious example, given that you've seen how that looks, a sort of sensible, naive implementation of how would you actually use this might look like that first example. I guess we're switching to Twitter now, but if you want to show a username, you could just pass in a string and pass in an options dictionary and that could parse it. But that has the exact same problem of everything is string typed. And as a third-party developer, it could be really easy for you to mistype something, and you're not going to catch that until runtime, which is not the best way to code. The compiler is great. We love the compiler. So the way this actually works is these handler objects each have semantic methods for all the actions you can do. And that works great as someone using this, but the code is kind of nasty. This is what the header file for that looks like. All the other handlers look kind of similar, and if you want to add a new action yourself, this is a whole lot of boilerplate. Each of these actions is 99% the same. And there are possibly ways to metaprogram that, but there are reasons that's not ideal either. And so this is a lot of code that I now have to maintain that I don't want to have to maintain. And it's really kind of ugly, but it's worth it because it means that we can get that really, really easy semantic method action for the other stuff, which, since that's much more common, it's worth it because it's often worth increasing complexity overall for the sake of decreasing it in the right places. So where does that leave us? I guess I've talked about a couple of different things. Here are cases where I made trade-offs and it seemed right. But this is a little different than a lot of other technical talks or even process-based talks in that, I can't say, I encountered this problem, here's a solution I found worked. If you have the same problem, you should try the solution. Because in many cases that'll work, but for the most part, it really is based on your code base. And a really weird thing I noticed when I was thinking about this talk is, I talked to a lot of friends, colleagues, people I really respect as programmers. And I tried to figure out, which are the ones who had really thought about maintainability and how do you write maintainable code. They were all the ones who have worked at places like Pivotal or Thoughtbot or ThoughtWorks, people who sort of had a professional interest in having opinion in this. That all the other good programmers I know, they sort of had this intuitive sense of, I know when I'm writing good code. But actively thinking about how this works isn't something that really happens until your code is no longer maintainable. So I guess I was really interested in saying, how can we start this discussion? That's about all I got. Thanks.
Thank you. Where do we start? That sounds... Guys, any questions? Well, I have one. Do you know this situation when you actually show this performance peak when you decide on actually rewriting the whole application right now? Do you know this feeling when you actually try to rewrite something, but you still need to add new features to the main application, and then you start chasing the main application and never actually finish the rewrite?
Yeah, I've been there before. I feel like that is one of the main reasons those giant boil the ocean rewrites tend to fail. And I think one of the reasons you really want to try to avoid them. I think once you're already in that situation, I think it's really difficult to find a way to get out of that. I think a lot of this is sort of prevention and finding yourself in a place where you don't have to do that. Yeah.
Have you thought about any metrics of measuring how maintainable code is?
Yeah, what's tricky is, so if you look, a lot of agile processes use stuff like measuring velocity, which can give you, that doesn't really tell you that much. That can really just be a warning flag of have things taken a serious dip. And again, there are plenty of tools. I think things are stronger in Ruby land or in other languages than in Objective-C, but there are static analyzers you can run that can tell you about potential code smells. Those naturally aren't going to be that applicable to your current situation, and it's more how well do you adhere to a standard. I'm not really sure what it might look like to actually try to come up with some more meaningful metric that's more quantifiable than the sort of fuzziness we have. I feel like it's one of those things where enough people have been thinking about this for so long that we might have had it by now if it was that easily possible.
Do you have any tips and tricks for resolving the tension between delivering the most maintainable code and delivering the features as fast as possible? Because from my experience, no one really is into delivering the bad code. It's only that the deadlines are coming always too soon, you know?
Yeah, definitely. I think a big thing is if you're in a team where this works, sort of try to enforce testing and documentation and those sort of practices as much as possible. Because if you can get buy-in from product that this is just part of the cost of doing business, that's good. That can be hard if you don't have sort of the right people to fight for that. Otherwise, I think as you're working, just thinking about modularity is so important. Whether that means focusing on immutable models and value types, whether that means dependency injection, whatever sort of modularity means for your code base, I think sort of reducing coupling in whatever ways you can is a really easy way to sort of keep code isolated and more maintainable without sacrificing too much in immediate velocity.
All right. I have one more actually. So you said that maybe if the application is really small, you don't have to do TDD, right? Maybe it's not the right tool. You can finish that application really fast and don't have to maintain a small code base, right? Having a test suite. Do you have an idea? Maybe you could actually share that. When should we actually pick TDD and dependency injection? How to see upfront whether this application is worth it or not?
I think most of the time, if you're asking that question, the answer is probably you should be doing things like testing. I think big picture, unless you know there is a very real chance you're going to throw this app out there and completely forget about it, which I think mostly tends to happen. If you're doing stuff in the art world, if you're doing stuff at early stage startups, if you happen to be working at the sort of consultancy where you just throw stuff over a wall and forget about it, and that's your success state. I think in general, most of the time, it's worth entering these practices from the get-go. I think doing stuff like full-on test-driven development and pairing can be really hard if you don't have buy-in from product. But it's often worth taking a stand and saying, no, this is something we need to do. We are going to regret this if we don't.
Thanks. Any other questions? If not, then thank you very much for your talk.
Thanks, everyone.